Our planet's surface tells an incredible story, a story written in stone, in ice, and in water. From towering mountains to vast flat plains, every single feature has a history. So, in this explainer, we're going to decode that story and uncover the powerful forces that shape the world we all live on.
I mean, it's a great question, and it really gets to the heart of what geology is all about. You know the world map as we know it? It's just a single snapshot in this epic, ongoing movie. The coastlines and continents you see were forged by these planetary-scale forces over immense stretches of time. So let's get into how it all works.
All right, so before we dive into all the details, we gotta see the big picture, right? Let's start from way up high with the two fundamental components of Earth's surface, land and water.
Okay, first thing you need to know, our planet is overwhelmingly a water world. Look at that number. Over 72% of the Earth is covered by a massive, continuous body of salt water that we divide up into oceans and seas. So what about the other 28%? Well, that's where we live, on the land.
Right, so that 28% of land, it's not just one big blob. It's broken up into what we call continents. Now, geologically, these are massive, distinct landmasses. But as we're about to see, the lines we draw between them, well, they aren't always as clear-cut as you'd think.
So we recognize 7 continents, from the absolutely massive expanse of Asia all the way down to the island continent of Australia. But here's an interesting little fact. That division between Europe and Asia, it's really more of a cultural and historical thing than a strictly geological one, since they both sit on the exact same tectonic plate, the Eurasian plate.
To help keep them all straight, some people use a little memory trick, a mnemonic device, like Sean got 3 A's to list them out.
Okay, now for that other 72%. An ocean is just this vast area of salty water filling up a basin on the Earth's surface. But what's really interesting here is that while we give them all these different names, it's technically all one giant interconnected global ocean.
We conventionally divide this single body of water into 5 named oceans. The newest addition is the Southern Ocean, which was officially recognized by many nations back in the year 2000, mainly because of its super distinct ecological characteristics all around Antarctica. And hey, just like with the continents, there are simple mnemonics to remember them, like Aunt Sally is a pirate.
Okay, so now that we've got the global layout, let's zoom in. The continents themselves aren't just flat pieces of land. They're actually made up of 4 major types of landforms, or what you might call Earth's building blocks.
So these 4 major landforms are basically defined by 2 things: their elevation, which is how high they are, and their relief, which is how rugged they are. Mountains and hills both have high relief, lots of steep changes. Plateaus and plains, on the other hand, are characterized by being pretty flat. The key difference there is that plateaus are elevated high up, whereas plains are down near sea level.
Now, of all those landforms, you got to admit, mountains are probably the most dramatic. So let's hit pause for a second and take a quick look under the hood at the incredible geological forces that actually build them.
The engine for mountain building is deep underground. You see, the Earth's crust is a mosaic of these massive, shifting sections called tectonic plates. Their super slow-motion collisions are what generate the immense force needed to raise mountains.
So there are basically 3 main ways this plays out. First, you have fold mountains. This is when 2 plates collide and the crust just buckles and folds upwards. Seriously, imagine pushing the ends of a rug together. It's exactly like that. Second are block mountains. Here, pressure cracks the crust, and these huge blocks of rock get forced up or down along those cracks, which we call faults. And third, you have volcanic mountains, which are built up layer by layer from hardened lava and ash from eruptions over centuries. And of those 3 types, get this, fold mountains are by far the most common. In fact, some of the most famous ranges on the entire planet, like the massive Himalayas in Asia and the Andes in South America, were created by this incredible folding process. Now that we've covered the major building blocks, let's zoom in one more time. The Earth's surface is just filled with this incredible variety of smaller landforms, and each one tells a story about the forces that shaped it. Let's explore a few key examples.
First up, we've got canyons and valleys. I mean, just picture the Grand Canyon. These are features carved out by the relentless power of water and erosion over millennia, literally cutting through layers and layers of geologic time.
Other landforms are all about their relationship with water. A peninsula, like Italy or Florida, is a piece of land that juts out into the sea. An isthmus, on the other hand, kind of acts as a natural land bridge, like the one in Panama that connects North and South America.
In really dry environments, the wind is the primary sculptor, creating these vast fields of sand dunes.
But right in the middle of these dry landscapes, an oasis can form, where the groundwater table actually reaches the surface. It creates this little pocket of life in an otherwise really harsh environment.
And finally, way out in the ocean, we find islands. That's land completely surrounded by water. Some, like Hawaii, are actually just the tops of huge underwater volcanoes. Others, called atolls, are these really unique ring-shaped islands formed by the slow, patient growth of coral reefs.
So the crucial takeaway from all of this is that the Earth's surface is not static. I mean, these landforms might seem totally permanent to us, but on a geological timescale, they are constantly being built up, worn down, and reshaped by the powerful forces of tectonics, wind, and water. Which leaves us with a pretty fascinating final thought, doesn't it? If our planet is always in motion, what new mountains, new canyons, or maybe even new continents might exist a million years from now? The story of our world is definitely still being written.